Hi everyone, this is Vusi. We're starting a new section today, and we're looking at vectors. So let's do everything that you need to know with vectors. We'll touch different parts of vectors. So if you're new to this channel, please subscribe to our channel, and then there's a bell icon as well there. You can just click on it so that whenever we upload a new video, you can actually see the new video. So that would be appreciated. And then otherwise, let's just jump into it. So we'll be doing vectors. And that's what we'll be doing. So generally they say it's vectors and scalars or scalars and vectors. It doesn't matter. So we'll be doing vectors and scalars. So the easiest thing to start with is a scalar. Like what is a scalar? So if you're doing grade 11 or grade 12, you should by now have come across these concepts. Right, and then if you're at varsity, you should be revising these concepts when you come from high school to university. So a scalar is a quantity. So since this is physics, there are vectors and scalars in maths. So in maths, a scalar is just a number. So in physics, a scalar is a quantity. That only has, that only has magnitude. What do you mean by magnitude? Do you remember that I mentioned this in some of the earlier lectures, that you may start talking about magnitudes. Basically, magnitude is size, how big that thing is. So we only care about how big that thing is. Now, an example of a scalar is like distance. Distance would just be 5 kilometers. So okay, so you're measuring distance, how big, so the size of the distance is 5. Of course, this is the unit, the kilometers. So this thing here, 5, is the size. How big is that scale? Or you normally hear people in physics say this is the magnitude. Alright. Now, one thing to note is that the magnitude is always positive. Right? The magnitude is always positive. It's always greater than 0, so it's always positive. So when you are asked a question in a test or in an exam or an assignment, whatever it is, and then they say find the magnitude, so you find that you're calculating, you get a negative answer. Don't leave your final answer as negative. The magnitude, the size of that thing is always positive. You will see sometimes why you get negative numbers or answers, so you just see as you continue, and then I'll explain where the negative comes from, what the negative means, and all of that. But otherwise, the magnitude is always positive, right? Another thing that is a good example of a scalar is time. Time, you just have 2 seconds, right? So you only have the magnitude. Of course, the unit, we don't care about the unit. In this sense, we don't really focus on the units. Not that we don't care, we don't focus on the unit. But you are only interested in what does it have. It only has this thing, which is the size, so it only has the magnitude, right? So I think you now get the picture, right? It only has the magnitude, size. Okay, right. Now in mathematics and also in physics as well, because we can do that in physics as well. So in mathematics, we also do talk of scalars, and you can just think of scalars as just numbers. Right? So a scalar would be just a number can be considered a scalar. In mathematics, for instance, when you get to varsity and then you start doing maths 101, or maths 1, whatever it is that they call it at whatever university that you're in, you will talk about scalars, and this is just a number. Any number like 1, 2, 3, 4, blah, 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 blah is a scalar, right? It doesn't matter what that number is. Right, so that is just a scalar. So you can think of a number as a scalar. You can think of a physical quantity with only the magnitude, no direction, only the magnitude as a scalar. So in physics, I think of scalars. Whenever people talk about scalars, think of it in that way. Like it's either a number or it's either a physical quantity where you don't actually care about the direction. For instance, this distance 5. We didn't tell you that it's 5 kilometers north, south, or east. We just said it's 5 kilometers. So, which means that we don't care whether they are coming from which side or going to which direction. You're just saying, look, they covered 5 kilometers. That's it. So we're just giving you the size of the distance that they covered. It's 5 kilometers. That's it. So it's a scalar. And then a number also is just a scalar. Now, this now leads us to the difference between scalars, and then it makes it possible for us to introduce vectors, right? So let me change the color. So we can now introduce vectors. What are vectors? Well, vectors, they have the magnitude, so they also have the size, magnitude, and they have direction. So something is not a vector if you're just talking about the magnitude, right? So you must, whenever you talk about a vector, you must have a magnitude and direction. Now, normally you'll be starting somewhere, and then you're going somewhere, you end up somewhere. So when you draw a straight line from the starting point to where you are going, and then you draw an arrow to say, this is, I'm from here, and then I ended up here, this is what we call a vector. And of course, the direction, it depends. So let me start with the easier one. Like if I start here and I go up, this is a vector, right? We can call this vector vector A. So let's call it vector A. Now, to show that this is a vector, we normally write this sign here. Some people will write like A and then they'll have this arrow here, right? And I think some people may do it like this, but I doubt that most people do it like this, but maybe you may see something like this. But generally, these are the two common ones to show that this is a vector. So I don't think you'll see this one that much, right? You either see something like this or you'll see something like this. And then this shows that this is a vector. So they are saying that whatever A is a vector, all right? So we can call this vector maybe B. Right? So this is just a vector pointing upwards. So the size of this vector, for instance, if I want to just write the size of this vector, I will not put the head on top here. What I will do is I'll just write A. So for instance, if I say to you A is 50, right? So I'm telling you that this vector is 50 whatever long. So it can be 50 units, 50 kilograms, 50 can be kilograms because mass is not a vector, like 50 meters if it's a displacement, because you do get displacement, or 50 meters per second. So I'm telling you the size of this vector, how big that vector is. So for instance, I could say this vector, I just write it like this, and I write it like this, and I say 75 units, for instance, right? So I'm telling you that this vector is 75 meters long. That's how long this vector is. So the size of that vector. So if I write B without this head thing, this arrow thing on top, right? So if I do that, now what I have done is I'm telling you only the magnitude of this vector. The direction of that vector, you can get it from the drawing, right? So it's different. They can ask you the question, or they can tell you a certain vector A is 75 units. Then they must tell you the direction as well. So they can't just leave it at 75 units. They must tell the direction. Now this one, the direction of course will be given by the angle here, theta, right? So the angle theta is going to be what is going to be the direction of this vector B here. Alright, so that's the difference between vectors and scalars. So you could have a vector that is going in this way. So this one is in the x direction. Let's call it vector C. And maybe the magnitude of this vector C can be 20 units. So I'm just putting units, which is just general. It could be anything. It could be force, like Newton. It could be meters, which is like displacement. It could be anything. But the most important thing is it starts somewhere, it ends somewhere. So it is 20 units long. That's how long the vector is. And this one is pointing in the positive x direction. So I'll get into those things of direction later on. So this is the difference between vectors and scalars. So I think for this video it's enough. We can stop here, and then in the next video I'll continue from this. Alright, cheers guys.